In this video, we're going to take a look at how to find the angle between two planes in 3 dimensions. If you look at this diagram, you can see that if we've got the plane, what we'll call plane number 1, the normal vector to that plane would be this red vector, wouldn't it? And then we've got the second plane, which is the green one. The normal vector to that plane would be pointing in this direction. Okay. Really common theme that comes up with, like, when you think about angles and directions of planes, you've got to use the normal vectors, like, because the thing is, we mentioned this in a couple of videos earlier, like, if you think about the plane itself, if you take a vector within that plane, there's like an infinite number of possible vectors that lie in the plane. So we can't really use a vector within the plane, it doesn't tell us enough information. The normal vector is the one vector that can help us describe the orientation of this plane, isn't it? Okay, and if you see from this diagram, like, the angle between these two planes, we can call theta here. You could also write theta over that side as well. Okay, there is an obtuse angle between the two planes, and there's an acute angle between the two planes. Obviously, depending on which one we want, we could just do 180 minus to get the other answer. But if we wanted the angle between the two planes, think about this green normal vector here. We know that the normal vector is perpendicular, so this angle here is a right angle. So if that's the angle between the two planes, let's call it theta. That's a right angle. That angle there would be 90 minus theta. We also know that if we look at the red plane, that normal vector there is at a right angle to the plane. So we know that these two angles add up to 90. So if that's 90 minus theta, that's also theta. In other words, this angle between the two planes is the same as this angle between the two normal vectors. Okay, so once we know that, we can relatively quickly find the angle between the two planes, especially if it's given in this form. If you look at example 1, it says find the acute angle between these two planes. So if this plane is written like this, I know that the normal vector to that plane would be 4 minus 1, 5. And I know the normal vector to this plane would be 1, 1. Minus 3. So the problem really breaks down to find the angle between these two vectors, because these two vectors represent the two normal vectors for the two planes. Did this last year. If you want an angle between two vectors, we can use this cos theta formula, can't we? Okay, so I would say cos theta would equal the dot product divided by the magnitudes. I'm not going to write the magnitude. I'm just going to do the calculation for the magnitude. So the magnitude of this vector is just Pythagoras. So that'd be the square root of 4 squared minus 1 squared, 5 squared, and the magnitude of this vector would be 1 squared plus 1 squared minus 3 squared. Okay. So when we do a dot product, we just multiply and add, so that'd be 4 plus minus 1 plus minus 15 divided by the square root of 16 plus 25 plus 1 times by the square root of 1 plus 1 plus 9. And then, obviously, I mean, the funny thing about this is, I know most of the time we're working in radians, but you can actually work in degrees. There's no calculus involved, so we can represent the angle between them in degrees, or we can represent the angle in radians. Most of the time in vectors, they actually use degrees, so I'm going to do this in degrees. Let me just use the calculator and see what we get. Okay. So I'm guessing I'm going to be in radians because I normally am, yeah. So I'll put it into degrees. And then we've got minus 3, minus 18. Okay, so shift cos inverse of not minus 18. We've got 3 minus 15, so that'd be minus 12. Divided by square root of 16 plus 1 plus 25 times by square root of 1 plus 1 plus 9. Okay, so that gives me cos theta, sorry, theta itself, because I've taken cos inverse, is 100 23.938. Okay. So think about what's gone on there. The reason that we've got an obtuse angle, by the way, is because, see the dot product on top? This dot product is negative. So if you think about it, whenever you get your dot product, if you choose two vectors, if you dot product them and the answer is negative, you know the cos is going to be obtuse. Like if the whole thing itself, cos theta, is a negative thing, the angle is going to be obtuse, isn't it? But if we want, specifically we want the acute angle between the two planes, what we've done here is we've calculated the obtuse angle between them. If you think about what it looks like, if we had two planes here, we know the obtuse angle between the two planes is 123.938. So if we want the acute angle between them, we would simply say therefore the acute angle would be 180 minus, which would give us 56.06 degrees to two decimal places. Okay, so once we've done that, the next thing we're going to look at is the angle between a line and a plane. Okay, maybe pause the video and draw a quick diagram and think about what, if you had a line which intersected the plane, how could we get the angle between the line and the plane? Try and visualize that before we see on the next part of the video. Okay, so we've got a plane and we've got a line that comes and cuts through the plane. And what we're aiming to do is get the angle here between the line and the plane. Okay. The thing is though, again, with planes, there's loads of possible vectors that can lie in the plane. But there's one vector that's going to be really useful when it comes to thinking about the orientation of the plane. So if we think about the normal vector instead, we see that the normal vector would be here. And the good thing about the normal vector is we know that that's wherever, no matter where we are on the plane, the normal vector is always perpendicular to the plane, isn't it? Okay. So if we wanted this angle here between the plane and the line as it cuts through, and we know what the normal vector to the plane is, can you see that if we work out this angle here, if we work out the angle between the line and the normal vector, the angle we want would just be 90 minus that. So it's going to be 90 minus the angle between the normal and the line. Okay. So let's try an example and we can see what happens. So the example says, find the angle between this line here, 407 plus lambda 332, and the plane 5x minus y plus z equals 7. So if you think about our diagram here, this normal vector to the plane, if it's written like this, would be 5 minus 1, 1. And the line is going in the direction 332. So if we want this angle here between the line and the plane, let's first of all find the angle between the line and the normal vector. Okay. So that angle there, we could say cos theta would equal dot product on top divided by magnitudes so we'll say cos theta would equal 15 plus minus 3 plus 2 divided by the square root of 25 plus 1 plus 1. 9 plus 9 plus 4. Okay. Notice that this one, the dot product is going to be positive, so we're going to get the acute angle straight away. Okay. It doesn't specify, it doesn't say the acute or obtuse. Like if you think about when a line and a plane intersect, there is going to be an obtuse angle and there is going to be an acute angle, but this one just gives us the acute one straight away. So cos theta would equal 14 divided by root 27 times root 22. Let's see, again I'm in degrees, so if we do 14 divided by root 27 times by root 22, so we know cos theta would equal. Sometimes in the question as well, it'll say like show cos theta equals, and obviously at that point you don't need to take cos inverse. If you don't want the angle, you could stop at that point. But obviously if you want the angle itself, so cos inverse, I'm getting 54.94 degrees. So 2 decimal places. Okay. The last thing we need to look at is how to find the intersection of 2 planes. Looking at the time of the video, I think I'm going to leave that, and we might do that in the next video, guys. Okay, so we know how to find the angle between 2 planes. The angle between 2 planes is just the same as the angle between the 2 normal vectors. The angle between a line and a plane, don't forget you've got to do 90 minus if you find the angle between the normal vector and the line. Okay, nice one, guys.